Okay, let's go through these problems. So this first page here is really about unit rate. So it talks about unit rate per pound. This is talking about rate again, average speed in miles per hour, price per pound. So really we're talking about something per something else, and we use a fraction to say that. So this one is saying $3.36 per 1.4 pounds. And this one is saying 7.5 miles per 3/8 hour. So 7.5 miles every 3/8 of an hour. And then this one is saying $3 for every 2/5 pound of meat. So really all of these represent that same idea of like a certain amount per something else. And so really, if you're going through and solving these, you would have to do the math for them, which hopefully that part of it feels pretty much like something you're able to handle on your own. So if I'm looking at 3.36 divided by 1.4, I end up here with 2.4. If I do 7.5 divided by 3/8, so 7 times 2 here is 14, 15. So this is really saying 15/2 divided by 3/8, which is really the same as saying 15/2 times 8/3, right? Because I can reciprocate this and flip my operation there. And then if I go straight across, 80 plus 40, 120 divided by 6. So 20 for this one. And then for this one, if I'm doing $3 divided by 2/5, so this is saying 3 divided by 2/5. So it's like 3/1 divided by 2/5. So really, if I reciprocate, right, and flip that, it's saying 3/1 times 5/2, which is 15/2, which is 7.5. So you can definitely go through here and find those answers. I just like to point out the idea that you're talking about dollars per pound here. So this is dollars per pound. And then here you're talking about miles per hour. So this is 20 miles per hour. And then here you're talking about dollars per pound again. So this is $7.50 per pound. So hopefully that felt like something you could handle. I know fourth period didn't seem to have any questions on that. We all talked about this idea, right? That if you're talking about tables that start at some place other than the origin, so this one would be starting at 0.10. This one would be starting at 0.5. But the idea is still the same, that you can't really do anything with this if it's not starting at the origin. It's definitely a no, not proportionate. So then if I'm checking ones that do have a point at the origin, I can go through and compare my fractions and say 5/5, 10/10, 20/15. What? Already I can say that's definitely not equal, right? So I know right away this is a no. So hopefully this is a yes, or there's something wrong. So let's see. 15/5, 30/10, 45/15, and 60/20 all reduces down to 3. So this is my constant of proportionality. Alright, moving on. Katya, we talked about her already. This idea that I have points here, and then I have another point here, and then another point here. So if I turn this graph into a table, then I can do what I just did, right? I can go through and just compare the ratios to see. So I have a point at 0, 0, another one at 580, and then finally 10 160. So if I set up all these ratios, 80 over 5 is the same as 160 over 10. So hopefully you can tell that all this reduces down to 16 over 1, or just 16. And if we're talking about, you know, y's on top and x's on the bottom, y's are dollars. So that means you're talking about $16. And x's are hours. So you're talking about every 1 hour. So this is $16 an hour. Okay, setting up a proportion, this is saying $63 per every 1.5 hours of work. That's how much this piano tuner charges. So if we want to figure out how much they would charge for 4 hours of work, I just have to make sure I set up fractions where the units match. So I have dollars on top and hours on the bottom, so that means I need dollars on top and hours on the bottom here. And so really what you're paying attention to is what's diagonally across from each other. So since I have 63 and 4 here, that's what I'm looking for. So first of all, I can eliminate this answer right away. I don't know why it has 3.5 and 2.5, but that's not even the right numbers. So if I'm looking here, 63 is across from x, so that's not right. And here, 63 is across from 1.5, so that's not right. The only one that has the right combination, 63 and 4 across from each other, like this one, is D. So it has to be D. So the only one that will give me the correct answer is D. Okay, moving on to 7. So here, same idea, I'm setting up proportions, but this time I'm solving. So I have 4 teachers for every 68 students is the same as some amount of teachers, right? So this is some teachers for 425 students. So here's my relationship, and I'm trying to figure out how many teachers that's going to need to be for supervision. Or I guess just for teaching in general, huh? So the key is those diagonal numbers, because what we do is we multiply them. So really I would need to take 425 and multiply by 4. So this is called a cross product. So you're multiplying the ones that are across the equal sign from each other. And then here I have 68 and I'm multiplying it by the question mark. So I'm basically saying 68 times something is going to be the same as 425 times 4. This is the beauty of proportions. This works because this cross product idea is equal because they're proportionate. So 425 times 4 is 1700. So really I'm trying to figure out, if you call that question mark an x, I'm really trying to figure out 1700 equals 68 times what? So I have to divide out that 68. So I end up here with x equals 25. Okay, as I'm moving on here then, same idea for this problem. I'm going to go through, make sure that I can tell which ones are proportionate. So 1 over 1, 4 over 2. What? Right away, that's not equal. So this is a no. Alright, 3 over 2 is the same as 5 over 4. That doesn't seem right. Right? And then if I keep going, 7 over 6. So that's definitely not true. So this is definitely a no. I can't reduce those to be the same. Alright, 1 over 2, 2 over 4, 3 over 6, 4 over 8, and 5 over 10. All of these reduce down to 1/2, right? So this one's a yes. So they are all proportionate. And then 3 over 1, 6 over 2, 9 over 3, 12 over 4, 15 over 5. So this also reduces down to 3, right? So this is also a yes. Alright, we talked about this yesterday. I was a little concerned that I had taught it wrong to first period, so I almost taught it a different way fourth, and then I realized afterward that it was fine the first way, so I should have instincts. So if we go through this here, basically I have, this is like 7.5, right? So it's like the relationship is basically saying that there's some number that I can multiply this by and that by to kind of like turn one shape into the next. And so the idea is that this relationship between these is the same. So 7.5 has the same relationship with 9 that 10.25 has with 12.3 and 16.75 has with 20.1. So really what I'm trying to do here is I'm trying to create a relationship between the sides, right? So I'm comparing the side of the triangle with the bottom of the triangle. So that's the ratio I'm creating. And so realistically, if I go through this, 7.5 divided by 9 is 0.833. Which that doesn't seem like it matches any of my answers, huh? Right? So this is really 5/6. So the question is why? And it's because when you're talking about geometric shapes, it doesn't really matter the direction you go. There are different ways to look at it so that you're getting bigger or getting smaller when you're talking about similar shapes. That's what these are, is similar shapes. So there's a way to turn them into bigger shapes and smaller shapes depending on what you're multiplying by. So we talk about the constant of proportionality in 7th grade, but later in 8th grade and then definitely in 10th grade later, this idea when you're talking about geometry turns into scale factor. And scale factor can be flipped around because sometimes you use scale factor to shrink a shape and sometimes you use scale factor to make it bigger. So that reversal comes from flipping this around. So if you think about rewriting these as 9 to 7.5 and then 12.3 to 10.25 and then 20.1 to 16.75, so making the comparison the opposite way, that turns into 1.2. Right? And 1.2. So this is my constant of proportionality, which relates later to scale factor. Okay. This is just a unit problem again. It's telling you 3/4 of a mile. Oops. For every 1/4 hour. So if I divide those, 3/4 divided by 1/4, I'm really doing 3/4 times 4/1, which is really 12 divided by 4, and that equals 3. So it's really the same as saying 3 miles per hour. Miles of yarn per hour, I guess. So see? Okay, the graph shows the cost of flour, and so it's saying what is the meaning of the 0.00. So if you're looking at this, you're basically saying 0 pounds, right? 0 pounds and $0. So it costs 0 pounds of flour is $0 is really what that's saying. If you compare the other ones, you can kind of see that they're not true. Okay, what can be concluded from the information on the graph? So it says the point is 1:12, so 1 is the hours here, right? And 12 is the distance. So after 1 hour, they've traveled 12 miles. So it says he rode a total of 12 miles, which we don't know that, because what about over here? He rode some more, it looks like. And we also don't know if it's 11, so I'd say we don't know that. But we do know from this point that the speed is 1 hour and he goes 12 miles. So 12 miles every 1 hour. Another one where you're interpreting. So it says, what can be concluded from the information in the graph? So it's telling you time versus depth. So this is a time of 1 hour and a depth of 3 meters. So if we're talking about time in seconds, right, this is 3 meters every 1 second. All right, so now we have a woman filling the backyard pool. The line in the graph shows the relationship between the minutes that she has been filling the pool and how much gallons of water are in it. So it says, what's the meaning of 5:45 on the graph? So if I go over to 5:45, that's here. So basically I'm saying in 5 minutes, it was 45 gallons. So 45 gallons every 5 minutes. So it means the pool has 45 gallons in it after 5 minutes. It means the pool is being filled at a rate of 45 gallons per minute. No, not per minute, per 5 minutes, right? So that's not right. Pool is being filled at a rate of 5 gallons per minute. So no, not that, right? If we reduce this, 45 divided by 5 is 9 gallons per minute. So the unit rate on this one is 9, not 5. And the pool has 5 gallons after 45 minutes, not true, reversed. So A. Okay, solving this. 12 cars for 15 hours. And it says, due to a decrease in sales, the CEO has to cut the factory hours down to 10. So we want to know how many cars that can be. So for 10 hours, what would that rate create? So how many cars? So if you look, remember you're comparing the numbers that are diagonally across from each other. So you're looking for 12 and 10 to be across. So if I'm looking at what's across from 10, and I'm sorry, from the 12, here I have 10, so that looks good. 12 and 15, wrong. 12, 15, wrong. 12 and C, wrong. So it's definitely that one. Okay, the question for this one's here. Which of these represent a proportional relationship? But there's so many answers that they didn't have space for the question. So we're just going to go through these and look. 5.5 over 1 is the same as 11 over 2, which is the same as 16 over 5, or 16.5 over 3, 22 over 4, and 27.5 over 5. So if you go through and you reduce all of these, you will see that they all turn into 5.5. This first one. So this is proportional. This 5.5 over 1 is the same as 9 over 2. That is not true. So here I could multiply by 2 to turn it into 11, but here I can't, right? It's not going to work that same way. So this is a no. 0.25 over 1 is the same as 0.5 over 2, which is the same as 0.75 over 3, same as 1 over 4, 1.25 over 5, which is true. If I take each one of those and divide them, I do end up with that 0.25 at the beginning. Okay, 1.25 divided by 1. So I don't know what your instincts on this one are. As you're moving across this way, it's going up by 1.25 each time. So that tells me that as this is increasing by the same amount. So I can tell that that's definitely going to work. But, you know, we can double check to make sure if I use a calculator that all of these total up to that first one, which it does. And then probably this is a no, just based on average, but who knows. So I would say overall already this doesn't seem like it's going to work, right? So 0.25 over 1 is not the same as 2.5 over 2. This reduces to a lot bigger number than this one does. So this is a no. Okay, now we got up to these easier integer problems. Hopefully these weren't hard for you. If you owe me $3 and you bring $5 to school, that means that you have $2 left. So 2 plus 2 would give you 4, right? So if I solve that, that's one way I can make some comparisons about things that have the same value. And I could go through and solve these and see, right? So I could just see which ones have the same value. If I do that, so 5 plus 2 here is 7, and negative 3 plus 7 is a positive 4, so that's good. Negative 5 plus 3, that's negative 2, and then negative 2 plus 2 is 0, so that doesn't work. Negative 5 minus 2, so a lot of kids want to say two negatives make a positive here, but not true. So if you owe me 5 and you owe me 2, that means you owe me 7 altogether. So 3 minus 7 is negative 4. And then negative 3 plus 5 is 2. 2 minus 2 is 0. So we can definitely show that A is the only one that works. If you do division for this is really just saying 4 divided by 9. So you just need to do 4 divided by 9. So I'm sure you can figure that out as you go. That you end up with. Oh, sorry, not that, because if I'm paying attention, you need to make sure you put the repeating bar over the top. So it is 0.4 repeating is what you end up here with. This one, same idea, right? 6 divided by 11. So 6 divided by 11. And it says she has this answer. So what's her next step? So if she multiplies to get 55, right, then the next step is to take a 0 down. So add a 0 to the remainder 5, and then find the number of times 50 can be divided by 11. So hopefully that is something you already knew, and that seemed easy to you. Okay, this is just a reminder that when you subtract, really what you're doing is adding a negative number. So I just wanted to make sure you knew that. So this is this answer. So subtracting is really the same as adding a negative. Okay, fraction problems. So definitely need to be comfortable here with the idea that when you have these two negative signs together, it's like a plus. So this is like saying negative 1/5 plus 3/8. And so, you know, if you wanted to make common denominators here, you'd have to multiply. So you'd get negative 8 over 40 plus 15 over 40, if I use 40 as a common denominator. So really I'm saying negative 8 plus 15. So this is negative 8 plus 15 over 40. So you just have to solve that, because right there it's going to have the same denominator. So negative 8 plus 15 is 7. Oh, nice. Okay, so I get all this over here. So if you're just asking, oh, what's equivalent? Geez, I should have stopped talking long ago. It would just be A. You're just making sure you understand how to rewrite that. Okay, what's the result of this subtraction? So again, kind of like what I was saying before, two negatives don't make a positive when you're talking about adding and subtracting. This is like saying you owe somebody $4.20 and you also owe them $3.50. So how much do you owe them altogether? So it's really kind of an addition problem. You're combining them to get 7.7, but then it's an O, like you owe that, right? So it's negative 7.7. Oh, you can finish this. Okay, more integer problems. Negative 16 minus 23, so owe 16, owe 23, means you owe 39. And then if you owe me $39, but you bring $7 to school, you can pay me back that $7, but you're still going to owe me 32. So it's kind of like a money problem when you're adding and subtracting. Which expression is equal to 0? So, a times negative a is like negative a squared. So that's not true. A plus a negative a, so this is like adding the opposite, right? So this does equal 0. Which means these shouldn't, but let's double check. So a divided by negative a is negative 1, right? Because the a's cancel out, but you have that negative sign left. And then a minus a negative a, this is really plus. So this is the same as saying 2a. So notice a times a is a squared, but a plus a is 2a. All right, evaluate the expression. Look at all those negative signs. So the first thing I'm going to do is get rid of the two signs that are together. That was what my teacher taught me. So 8 minus, and then I have 12 plus 4. So two negative signs together make a plus. And then I have to do what's inside the parentheses first. So that's 16, right? So 8 minus that 16, which really equals negative 8. So if you have $8, but you spend 16, then you're going to owe somebody $8. All right, parentheses first. 2.7 minus 6.8. So if you have $2.7 and then you spend 6.8, really that means you're going to owe somebody money, right? So you're going to owe $4.10. So this is really saying 4.5 minus 4.1. Oh, sorry, negative 4.1, because really you're subtracting that, right? So this negative and negative, since I'm subtracting here, that's this sign. But I also have a negative sign here, right? So this negative sign and that negative sign are with the 4. So I need to rewrite this with a plus. So it's really saying 4.5 plus 4.1, so that equals 8.6. Okay, I have negative 20 minus 8, and then I'm dividing by 4. So this is a grouping symbol when you have a fraction bar like that, so I have to handle that first. So negative 20 minus 8, if you owe me 20 and then you also borrow another 8, now you owe me 28. And I'm dividing that by 4. So this is where the other signs come in. So when you're adding and subtracting, it's a lot like money. But when you're multiplying and dividing, you can just memorize the rules. And the rules I usually tell students are, you can have two positives, two negatives, or a positive and a negative, right? So those are their things when you're multiplying and dividing. So if it's positive and positive, that's like when you wake up in the morning and you're excited to go to school, so it's good. Negative, negative is like you're tired and ready for bed. It's bedtime, so you're happy. Wow, I really messed that up. Sorry, my kids are talking in the background. I got distracted. Here, this is when you're happy. See, forget all that. This is the problem one, because this is when you get punched in the eye. So this is when you're sad. So if you have two positives, it's positive. If you have two negatives, it's positive. But if you have a positive and a negative, that's negative. So in this situation, since I have a negative number and a positive number, this is really going to be a negative 7. If you're looking for this expression matched here, one thing you could do is just solve these, right? If I go through and see that negative 5 plus 8 is 3, then this doesn't work. If this is negative 13, then that doesn't work. Negative 5 plus 2 is negative 3, so that doesn't work. This is really the expression that's going to give me that negative 7, right? I'm going to guess some of you would probably be a little confused between these two, and it's because what they're doing is they're splitting this denominator between both numbers on top. So negative 20 and negative 8, so you're dividing each one individually, so you end up with negative 4 and then that minus 2. That's where that comes from. Okay. 6/11ths written as a decimal. So I feel like if you do the long division on this, I'm sure you can figure out what it is. I'll just tell you. If you divide 6 divided by 11, you end up with this answer. So just make sure you set up your division right. Okay, what's the product of 1.7 and negative 3.2? So 1.7 times negative 3.2. So positive times a negative here definitely means that I'm going to have a negative answer, right? Two different signs. So 1.7 times 3.2 is 5.44. Okay. Almost done. Amber said the distance between the points A and B can be found using this expression. So basically, this is the absolute value which the absolute value is the distance from 0. It's how far away it is. So if you solve this problem, it kind of works like parentheses. You have to solve what's inside first. So the first thing I do is simplify. -7 minus 3, that's -10. So the symbol are these two lines on the side. That's absolute value. So this says the absolute value of -10. And so it's really saying how far away is -10 from 0 on a number line. And hopefully you can tell that that would just be 10. So another way to think of it is that absolute value is always positive because it's distance. So you wouldn't say, you know, you're -5 miles away from the store. It's always positive, right? So really you're looking for a number line that shows a distance of 10, right? That's the easiest way to do it. But you can also kind of pay attention to the numbers here. You start here at -7, and then you're subtracting a +3. So it's kind of like you can say you started at 3 and went backwards here to -7, but it's that distance between them. So there's 10 here. Whereas this is too small, this is too small, that's not enough. Okay, same kind of problem here. So which of the following describes the location of the number line for the sum of 4 and -6? So, I mean, you know, I understand, so this might work for some kids if the teacher taught it to you that way. It's kind of not really how we've talked about it. I mean, you can just do what you know. So the sum of 4 and -6, so this equals -2. So if you kind of look through these, you can kind of solve to find out which one would represent that idea. So this says the absolute value of -6, so that's just 6. This is the absolute value of -6, so 6. Absolute value of -6 is 6. So this is saying 4 units to the left of -6. So if I'm at -6 and I go 4 units to the left, it's over there, which that's not right. It's supposed to be -2, so nope. 6 units to the right of 4. So if I'm at 4 and I try to go 6 units to the right, it's going to be that way, which again, that's the wrong direction. So that's not right. 6 units to the left of 4. So if I'm at 4 and I go 1, 2, 3, 4, 5, 6, imagine that. So I start at 4 and I go 6 this way and I end up at -2, which is the answer here. So that seems pretty interesting, huh? 4 units to the right of 6, we already said that one didn't work. So yeah, that makes sense. Okay, this one, same kind of idea. So which one represents this? So 53 plus -16 is really the same as saying 53 minus 16. Because of that plus and negative together make a negative. Kind of like that punched face, remember? Plus minus makes a minus. So 53 minus 16 is 737. So I'm looking for something that ends up making this at 37, right? So it's going to end here. So $16 in a negative direction from 53. Well, that right there looks good, right? You're at 53 and you go $16 in the negative, and that ends you up at 37. So that's the right answer. It's not $37 away from 53. And then it's not $16 in the positive direction, right? Because it's a reduction, so those don't work. Okay, expression below, 6.2 minus 0.04. So we got to fill that in. It's 6.16, so 6.16 inside the parentheses, right? So really this is saying half of 6.16, which half of 6.16, wait, did I do this wrong or is this a mistake? Let's see here. 0.5 times. Oh. Yeah, no, that makes sense, right? Half. 3.08. So it would be. Alright. If you read through this expression, basically you're trying to find something that matches from here to here. And really the key is that this has one negative sign. So you need to find an expression over here that also has one negative sign. So if you look, this has a negative and a negative, so that doesn't work. This has a negative and a negative, and that has a negative and a negative. So two negatives are going to cancel out. This is the only one that has one negative sign like that one does. So that's a negative answer like that one is. Which of these expressions equals -5? So -30 divided by 6 is -5, so 1 works. Negative 30 divided by 6, so this is negative 5 like, 5 like this with the parentheses, but that's still the same as negative 5. So this works. And then 30 divided by negative 6 is also negative 5. So the only one that doesn't work is this with two negatives, right? Because that's the two... Why do I keep doing that? That's this face. So this doesn't work. So 1, 2, and 3. Okay, I think that's all of it, right? 35. The last question. Good job, everybody. If you watched all the way to the end, you really stuck to it. Thanks for your hard work. I appreciate it.